Pluto's way will undoubtedly cause issues. From the beginning, Pluto's circle meets that of another planet. Pluto, the strange and modest planet found in the farthest corners of our solar system, has turned into a hotly debated issue in astronomy. Recent updates suggest a potential crash with Neptune, raising alarms among researchers and space enthusiasts. Eminent figures, such as Neil deGrasse Tyson and Michio Kaku, have expressed concerns regarding the potential consequences of this cosmic encounter. But how did Pluto end up on a crash course with Neptune, and what could this cosmic conflict mean for Earth? Join us as we explore the details of how a massive event with Neptune could have occurred and why scientists are troubled by this vast anomaly. Pluto, once celebrated as a full-fledged planet, underwent a dramatic reclassification as a dwarf planet, largely due to its erratic orbit. Despite this demotion, Pluto continues to fascinate and spark interest within the astronomical community. Recent warnings from prominent scientists, such as Neil deGrasse Tyson and Michio Kaku, suggest that Pluto's path could intersect with Neptune, implying a potential risk of collision with serious implications for our planet. Pluto's journey around the Sun is extraordinary due to its unique characteristics. Its orbit is incredibly lengthy, taking a massive 248 years to complete. Since its discovery in 1930, Pluto has not yet completed a full revolution around the Sun. What makes Pluto even more intriguing is the extreme elliptical shape of its orbit, in stark contrast to the nearly circular orbits of the major planets. Moreover, Pluto's orbit is tilted at an angle of 17 degrees relative to the ecliptic plane, resulting in a steeper inclination compared to the paths of other planets. This combination of inclination and its elongated orbit adds complexity to its movement. A fascinating aspect of Pluto's orbit is its repeated intersection with Neptune's orbit. Every 248 years, Pluto's path brings it closer to the Sun than Neptune, challenging expectations based on their relative positions in the solar system. Further investigation reveals that Pluto's orbit is far from a perfect circle. Instead, it follows an elliptical or oval path, meaning its distance from the Sun varies significantly throughout its orbit. At its closest point, Pluto comes within approximately 30 astronomical units from the Sun, but at its farthest, it stretches to more than 49 astronomical units, nearly double Neptune's distance from the Sun. Additionally, Pluto's orbit is tilted at an angle to the orbits of the other planets, adding yet another layer of complexity to its relationship with Neptune. This inclination plays a crucial role in how Pluto and Neptune interact. When their orbits intersect, their gravitational forces pull at one another, continually altering their trajectories. This dynamic between Pluto and Neptune highlights the interconnected nature of the solar system, with each planet exerting gravitational forces that influence the movements of others. Over the years, advancements in observational instruments have allowed astronomers to track Pluto's movement with greater precision. This has led to a better understanding of its orbit and its potential impact on the overall stability of the outer solar system. Although the likelihood of a direct collision between Pluto and Neptune remains low, the possibility is still under scrutiny. Ongoing monitoring continues, as the potential consequences of such a collision could be dramatic. Despite Pluto's small size and distant location, it remains a subject of interest for scientists and space enthusiasts alike. A key question arises: why hasn't Pluto collided with Neptune already? The answer lies in the gravitational influence of other planets. From the moment Pluto was discovered, astronomers have been trying to understand its path. Unlike most planets, which maintain a consistent orbit along the ecliptic plane, Pluto's orbit stands out with its steep angle and elliptical shape. The mystery deepened when it became evident that Pluto's orbit crosses Neptune's. Despite this apparent danger, Pluto's orbit remains remarkably stable, illustrating the intricate mechanics that govern space. Studying the interactions between Pluto, Neptune, and the Sun presents a formidable challenge for astronomers. Predicting their movements requires a deep understanding of how they influence each other's trajectories. To navigate this challenge, scientists rely on concepts such as apsidal libration, scope libration, and VSOP, variations séculaires de orbits planétaires. Apsidal libration, for instance, is essential in maintaining the stability of planetary orbits. When Pluto crosses Neptune's path, it remains at least 90 degrees away, preventing a direct impact. Scope libration ensures that when Pluto approaches Neptune or other large planets, it is positioned above their path, reducing the likelihood of a collision. The VSOP oscillation, named after scientists von Zippel, Steves, and Kaplan, explains why Pluto's orbit appears unusual yet remains stable over time. Even though space seems chaotic, there are underlying patterns that help maintain order. These patterns are responsible for preventing Pluto from colliding with Neptune or significantly altering its orbit. The concept of orbital chaos, which describes how a celestial body's trajectory is highly sensitive to its initial position, is clearly demonstrated by Pluto's orbit. Even small variations in Pluto's position or speed can have significant effects over long periods. Scientists use advanced simulations to model Pluto's interactions with other bodies in space, such as Neptune, and to explore the consequences of even minor changes in its trajectory. In the late 1980s, these simulations revealed something fascinating. Despite the apparent stability of Pluto's orbit, it can still behave unpredictably. A slight modification in Pluto's starting point or speed could lead to substantial changes in its orbit over time. However, even with these uncertainties, Pluto's orbit remains stable for billions of years, suggesting that, despite its erratic appearance, it follows an underlying order. The unpredictability of planetary orbits, such as Pluto's, makes it difficult to predict long-term changes with certainty. These models require highly accurate initial conditions, as even small errors in data can produce vastly different outcomes, making precise predictions incredibly challenging. Understanding Pluto's orbit is essential, especially when considering the potential for a future collision with Neptune. This knowledge contributes to a broader understanding of how our solar system operates. Pluto's orbit serves as an example of how seemingly chaotic paths can ultimately reach a balance, guided by the forces of gravity and motion. We must continue to observe and study these celestial mechanics to gain a better understanding of our place in the universe. Pluto's orbit offers an ideal illustration of the unpredictable nature of space. Pluto's orbit is unlike that of the other planets, with its oval shape leading to eccentric encounters with Neptune. This irregular motion makes it challenging to predict the long-term dynamics of the system. However, gravitational forces play a crucial role in preventing Pluto and Neptune from colliding. Gravity, a force that attracts objects to each other, ensures that, despite their intersecting orbits, the two bodies remain apart most of the time. These interactions reflect the delicate balance of forces at work in space. The possibility of a collision between Pluto and Neptune, while unlikely, would be a monumental event with significant consequences. Such an event would dramatically alter our understanding of the solar system. Although space exploration has come a long way, Pluto's orbit serves as a reminder of the many uncertainties that still exist. Scientists continue to study Pluto's path to better understand how large planets influence its motion. This knowledge is crucial for understanding the intricate relationships between celestial bodies and how their movements can affect one another. Despite the unusual nature of Pluto's orbit, some of the world's leading scientists, like Neil deGrasse Tyson, have speculated that Pluto might one day collide with Neptune. Tyson, a prominent astrophysicist, sees Pluto's reclassification as a dwarf planet as a necessary step, emphasizing the importance of continued exploration and study. He believes that Pluto's eccentric orbit highlights the fact that there is still much to learn about space and the forces at work within it. According to Tyson, the mysteries of space are what makes studying it so captivating, and he encourages others to engage with the fascinating complexities of celestial mechanics. Tyson, along with other experts, is concerned about the potential dangers posed by Pluto's unusual path. If a collision between Pluto and Neptune were to occur, it could have devastating ramifications for our solar system. The release of energy from such an event would be enormous, and the debris scattered throughout space could have far-reaching effects, potentially even impacting other planets and moons. Neptune itself would be affected, and its orbit could be altered, further complicating the dynamics of the outer solar system. Renowned theoretical physicist Michio Kaku, known for his work in string theory, also provides valuable insights into space exploration. Kaku believes that studying phenomena like Pluto's orbit is essential for understanding the broader principles of celestial mechanics and theoretical physics. He suggests that the study of Pluto's interactions with Neptune can help scientists navigate future space missions more safely.